It is time to kick off the startup battlefield. This is TechCrunch's legendary pitch competition. The next generation of startups will be taking the stage to compete for $100,000 in equity-free prize money and the Startup Battlefield Cup. There are 200 Startup Battlefield companies here at Disrupt. We're not going to see them all now. We're going to see 5 of the top 20. And those 5 companies are going to be competing for a slot in the finals on Wednesday. Each presentation will be 6 minutes of pitch and live demo, and then 6 minutes of Q&A from our expert judges. And you remember I mentioned an event app earlier. By the way, has anyone downloaded the event app already? Raise your hand if you downloaded the app. Excellent. All these cool people, they can go into the app. There is a polling section in the app and share which company you think should win. And with that, let us bring out our judges. I'm going to be introducing them as they come out. First up is Allison Baum-Gates, a general partner at Semper Virens Venture Capital, a venture fund investing in healthcare, fintech, and enterprise SaaS. She is the author of Breaking into Venture and the forthcoming Beyond the Pitch, The Psychology of Raising VC Funding. Next, we have Kathy Friedman, the executive venture partner at GV, where she advises the life sciences portfolio and invests across the healthcare continuum. Her interests include adolescent mental health, the full lifespan of women's health, and more equitable systems for the underserved. Next, we have Caitlin Holloway, founding partner at the early-stage venture firm 776. She is a seasoned investor with over 20 years of operational experience at companies like Pixar and Reddit. Next, we have a veteran of the Disrupt stage, Charles Hudson. He's managing partner and founder of Precursor Ventures, an early-stage VC firm focused on investing in the first institutional round of investment for the most promising hardware and software companies. Under his leadership, Precursor has raised 4 funds and has more than $250 million under management. Next, we have Nicolas Sauvage. He's president at TDK Ventures. Yeah, we got a Nicola fan there. He is president at TDK Ventures, the corporate venture capital arm of TDK Corporation. TDK has backed 45 startups under his leadership, including 3 unicorns. Give it up for our incredible judges. Okay. I'm going to stop talking now because it is time to bring out our very first startup. That startup is MacroCycle Technologies. Presenting for MacroCycle is co-founder and CEO Stuart Pena-Feliz.
Today, over 99% of all the textiles waste that are globally produced ends up in our landfills, in our oceans, or it is even incinerated. A linear economy growing to $3 trillion, polluting our environment, shedding microplastics, impacting our health, and we haven't had the technologies to resolve this dilemma. If a brand wants to acquire recycled polyester textile material today, they need to source it from bottles, because the technologies of today, mechanical recycling, cannot handle with the complexity of the garments that we wear on our daily lives, leaving disposal as the most viable option. The technologies that can address this quality dilemma, the advanced recycling technologies, are then too energy intensive. They rely on breaking the bonds of the polymers in the textiles down to the building blocks, and then having to undergo all the traditional petrochemical steps to arrive back to the original polymer. This means that if a brand wants to acquire recycled material through this technology, they need to pay a green premium, inhibiting its adoption because of its high costs. MacroCycle is able to resolve both of these dilemmas thanks to our creative approach. Instead of breaking bonds, we are making new ones. Through our patented Solvo Genesis platform, we're able to retain all the energy that went into making the original polymer. And instead of breaking it apart, we force it to bond with itself to create a new intermediate called macrocycles. These intermediates allow us to bypass the petrochemical industry entirely, and we're able to produce a high-quality product at a fraction of the cost. This is how our technology works. MacroCycle will acquire polyester-containing textile waste. And whether they're multi-fiber, multicolor, or multi-material, like the shirt and the pants that I'm wearing right now, we're able to go through our proprietary set of solvents and operating conditions to be able to remove the non-polyester materials, the colors and the dyes, and increase its chemical quality through our chemistry to produce our product. The MacroCycle polyester resin, a high-quality drop-in solution that the textile industry can use to make yarn and garments out of 100% post-consumer textile waste. And now to see this process live, we're going to switch over to our demo out of Cambridge, Boston, Massachusetts, where our engineers are going to show you our second step of the decolorization of the textiles. So right here, we can see the beaker with the textile waste, specifically with red dyes. And our upcycling engineer is about to put it through our systems. You can see it how she's pouring it into our solvent system. And very quickly, you can see how the liquid is mixing in with the color and basically removing that from the textiles. This is our magic. And very simply, we then put it through a rinsing and a washing process where you can see live right here how the solvent comes out with the color, while the material stays behind. It is that simple. Once she's done rinsing that, we repeat the process a few times, and the end product is a fully decolorized textile material ready to go through our process to be provided as a drop-in solution. Em, thank you very much for the live demo, and with that, we'll be switching back over to the slides. You saw how simple it was. That allows us to be the first recycler to be able to claim that we can provide this material at price parity with the petrochemical industry. All thanks to our simple, resilient, carbon-free, non-toxic process. And now it is time to scale up fast. We incorporated a little over 2 years ago, but since then have been able to raise a few rounds of financing that has allowed us to scale up 1,500 times to be able to start addressing our customer pain points. And this is thanks to the fact that we are a chemistry-only innovation, not an equipment innovation. So we can leverage the existing infrastructure to be able to actually produce our product at larger and larger batches without having to put steel or capital on the ground. And this is allowing us to quickly start addressing our customer pain points, as represented by the fact that we're already generating over $350,000 in revenue from material sales and recycling services. This is into customers who represent over $1 billion in material purchases in fast fashion, footwear, and more. And this is only the beginning, as by the end of this decade, we aim to have the capacity to recycle half of San Francisco yearly textile waste. It may not sound like much, but this already accounts to tens of millions of dollars in revenue, and is simply just the beginning, as we'll be able to scale up our technology to build additional facilities and license our plan to be able to address this at a global scale beyond just polyester-containing textile waste. My name is Stuart Peña. I'm the CEO and co-founder, and I used to work at ExxonMobil's first recycling facility. After meeting my co-founder and the innovator of this technology at MIT, we have been able to onboard a diverse powerhouse of a team and a set of investors and advisors that have been through this journey many times before, giving us the confidence we have what it takes to get this venture off the ground. We have been incredibly fortunate to be supported by numerous great organizations, but we're still going to need more help. If you want to help us scale up our differentiated technology, or an investor interested in our future Series A financing opportunities, let's connect, because together, MacroCycle can create a cleaner, more circular future for everyone today.
All right, excellent. And 10 seconds to spare. Judges, who has a question?
I have a question.
Yes.
I'd love to hear a little bit about your competition. There's obviously the status quo, but who else is trying to get into this market?
Indeed, I am happy to answer the question while I'm letting you guys actually feel our product so you can feel how smooth it feels. Indeed, so this in the last few years has seen a lot more competitors come up, but to our knowledge, we're the only company that's able to increase the physical and chemical properties of the material without ever having to break down or depolymerize the polymer. That allows us to be significantly more energy efficient. If you hear and do research in the textile industry today, you will hear that the challenge, nice throw, is the ability for recyclers to provide this at price parity. Our customers don't want to pay a green premium, therefore no one wants to adopt this material. As soon as you lower the cost barrier, you can enable mass adoption, and to our knowledge, we're the only ones that have publicly been able to claim that we can provide this at price parity.
Are there pricing fluctuations in the textile itself that you have to accommodate for when you're selling it back?
That is a great question. So because this is a petrochemical derivative, the reality is, yes, there will be fluctuations based on the oil prices. That being said, there are ways for us to shield ourselves from those fluctuations, and that's by being able to sell the benefits separate from the material itself. For example, there are several companies out of San Francisco that are speaking with us regarding carbon offtake agreements, which are separate from the material itself that can provide it to the brand while they still are able to claim the circularity benefits, yet we can monetize the carbon benefits of our product.
Can you talk a little bit about just the corporate structure? I saw you mention a top co in there, and how do you think about the longer term capital needs for the business?
Indeed, that's a phenomenal question. So, as we all know, the market is not necessarily incentivized for big capital projects. And as a result, we're able to actually increase our capacity through contract manufacturing where we can leverage the existing infrastructure. That will allow us to prove the technology to a scale where the chemistry and the scale-up has been fully de-risked, and then we can go out there to build our first technology. Now, our first capital project that will allow MacroCycle to be profitable at a top co scale is a $40 million project, which compares to our competitors, they're building anywhere from $300 million to $1 billion projects. And that's because we can take advantage of the simplicity of our technology to reach higher profitability levels. Once we're able to demonstrate our technology, then that opens up a lot more avenues, including licensing. Our customers have told us, or potential licensing customers have told us, that they will not license a technology that has not been proven. And that works great. We can reach profitability at the top co level, and then we can increase the rate of penetration of our technology at a global scale through those business models.
So you touched on one of my questions, which was about scaling. Clearly, you're creating a lot of value. There's a challenge on value capture and scaling. But your plan is to become a licensing model or to capture some of the value yourself?
So the licensing model is our ability to be able to scale up at a global scale faster. But our first facility, once we de-risk it, we are going to own and operate ourselves to be able to capture the value. And then we see ourselves continue to do that in the regions that we have good connections and good knowledge of. For example, one of our largest investors is the family office of Indorama Ventures, based out of Southeast Asia. We can collaborate with them to be able to capture the market. But South America and so on, those are regions that we may not have the connections right now where we can license our technology to companies like Braskem and so on to be able to increase our footprint globally.
Okay.
Stuart, thank you for your pitch. You have the best energy. You obviously are super excited to be here and to be sharing what it is that you're working on. I saw you dancing backstage, and I think you could get excited about just about anything, which we love. I want to better understand, though, your passion for this particular problem. So I understand your background. I understand how creating this chemical and chemistry solution makes a lot of sense, and it feels cool. I don't know what a normal textile feels like, so I can't compare it to anything. But why are you waking up every morning, dancing, getting out of bed, putting on your polymer clothes, saying, yes, this is the thing I'm going to spend the rest of my life doing?
There's two experiences that have led me to be passionate about this. The first one is, as I mentioned, I worked at ExxonMobil's first recycling facility. And I saw the reality of the oil and gas industry and what happens when you try to recycle through those traditional steps. And to some degree, I almost say I want to wash my hands from what I've done by what I'm doing at MacroCycle. So it's kind of undoing a lot of those actions that I saw firsthand through this company. The second one is, I just went to the Dominican Republic, my home country, for the first time in a while this past Christmas and New Year's. And I went to one of my childhood places, which is called El Malecón. It's right next to the water and the ocean. And I remember, I literally had a picture in my phone of me as a kid, sitting in one of the bricks walls there. Water clear. You go to the same spot, Crocs, shirts, bottles, and it's just being filled with all of that. And when I think of the future, I want to remain optimistic, but at the very least, I want to give my kids a fighting chance to be able to live the world the same way I did as a kid. So I will admit that was not an initial passion when I started the company, but it's now reinvigorated my passion to try to do my best for the future generations. Those are the two reasons as to why I am passionate to do this and why I'm living the dream.
Do we have a final quick question?
I have one final quick question. Everybody talks about, green parity. What about the green discount to get people to really start using it? Where are you on that?
I love the question. our second facility will be able to provide a green discount. And the reason for that is because we can take advantage of our technical innovation among the economies of scale to be able to provide that. The reason there's no green discount today is because the petrochemical industry has had 100 years to develop the infrastructure. We've only had the last decade. Give us a few more, and we'll get there. Thank you, everyone, for your time. Truly appreciate it.
Thanks.
Give it up for MacroCycle Technologies. All right, we are going to bring out our second startup battlefield company. That company is Miracules. Presenting for Miracules is founder and CEO Sabir Hossain.
Namaste everyone, I'm Sabir. I hold a master's degree, PhD equivalent experience, and 11 patents in biomaterials. But today, I'm going to introduce you to this nanomaterial that will stop bleeding within a minute of application, potentially saving millions of lives worldwide. But before that, a quick heads up, my slides contains real medical images of bleeding and trauma, but they're really important to show you the urgency of the problem we are solving. In 2014, my father and I had a horrific accident. And I still remember my desperation and failure to stop his bleeding while I was rushing to the hospital. But this is not just about me. Many of you might have faced the similar situation. According to WHO, more than 6 million people bleed to death every year. That's like the number of people we lost during COVID. And the tragic fact is, almost 90% of them could be saved if bleeding is stopped early. But unfortunately, our standard of care are pressure and tourniquets. On the other hand, we have some single material-based products which often fail to stop severe bleedings. And that's why, during my master's, we came up with a process of combining the off-the-shelf materials into a new material altogether that will outperform those base biopolymers. We patented the process, and we strongly believe once this product comes into the market, it will positively impact the public health by stopping bleeding instantly. Now the science. So this is the world's first material to mimic blood clotting protein fibrins, and that's why it produces a very similar clot like a natural clot, but with a much more higher mechanical strength. Now, the demo. Let's go to our lab in India, to my colleague Shreya. Shreya, you are on the big screen. So what she is going to do is, she is going to test our product against the gold standard solution that is used by some of the major armed forces in the world, like US, India, Israel. So she has clocked it for 30 seconds, and she has added same amount of material to the same amount of blood. And as you can see, that it's going on, like we are just, if I see the timer correctly, we are just around 5 seconds left. That's it. That's what I was talking about. So back to the slides. So we also have tested our product in large volume of blood loss. This is a pig model. In such a case, a person can bleed to death in under 10 minutes. So here we have punctured one of the largest artery of our body, that's femoral artery, and then applied the product and then compressed it for just 45 seconds. As you can see, the bleeding got completely stopped, and if you keep it for another 20 to 30 minutes, you can simply take it out without causing any rebleeding. Just like that. So we are going to introduce this product in multiple variants to suit different applications. We are starting with emergency and armed forces with more than 700 million injuries every year. Our obvious next step is the surgical field with more than 300 million surgeries performed annually. But our audacious goal is to launch in every first aid box in the world. And we are going to introduce this product to our B2B and B2G customers via existing distributor networks and government tenders. And this is an unsolved market with more than $37 billion of opportunity, but that's not all. Our patented process also allows us to produce other nanostructured materials for different other biomedical applications like bone tissue engineering and wound healing with a combined market of more than $42 billion. Now, since beginning, we have involved doctors across different sectors in shaping our MVP. Currently, we have deployed our product at a trauma center in India, and now I'm going to show you some of the most severe cases that we are solving. So here I was talking about. And I'm very proud to share, like, not only it will save lives, but it will reduce the medical waste by around 99%. So right now we are waiting for our Indian approval, following which we'll start our paid pilots with some of the biggest hospitals in India. We are also working on our US FDA approval. Now the team we have with more than 100 years of combined research experience, I developed this product under my professor, Dr. Devendra Verma. Mubin was a medical practitioner before joining Miracules. Our other advisors have different knowledge and skill sets, starting from medical device validation till selling B2B. And these are our precious partners. I'm also very proud to share that to date, we have received a huge amount of support from several national and international organizations that truly validates the need for stop bleed. And we have achieved everything with just less than $800,000. But now we need funds to grow in India and USA. Lastly, I just want to conclude by saying, I was lucky enough to save my father, but not everyone. Your support could save those lives. Thank you.
All right, great job, Miracules. Judges, who has a question?
Well, this is amazing. Congratulations on the work you've done. Maybe can you speak about the biggest challenge for you to convince customers? It feels obvious for the end user. How about the supply chain? How do you get to the end user?
Got it, sir. So this is categorized as a medical consumables. So we are not exactly like reinventing the supply chain. It's like smart bandage kind of a thing. And our first targets are like ambulances and emergency theaters. So instead of using gauze or cotton bandages, they will be using stop bleed. So, and they already have established like supply chains. Hospitals in India, they have their paneled distributors from whom they purchase products and all. So our influencers are really doctors, and we are that's why these pilots are very much important, because they will generate the credibility as well as we will use the data for publications. They will influence the whole purchasing process.
Very nice.
Can you talk a little bit about how you're going to get the product into hospitals? Because there's a different standard for being on the battlefield than being in a hospital.
Right, ma'am. Ma'am, actually, getting into the battlefield is a bit more tricky, because then it involves government bureaucrats and all those aspects. In the hospital, it's again, it's a medical consumable. So we will just be comparing it with the gauze itself that they are using right now.
And is it manufactured to be sterile so it can be in a hospital as well?
Yes, ma'am. It has to be sterile.
Is there any training, or how does it affect the operations of a hospital to roll out this product?
So that's actually the best part. You don't need any training to use this. It's as simple as just apply and compress. That's it. Nothing else. So anyone can use it. And our most audacious goal is to launch in every first aid box in the world. Like in India, in every nook and corner, there should be small these kind of units. And this is actually for the battlefield. So this diameter is actually a size of the exit bullet wound. So they can simply, without accessing this, they can simply push it to the.
I'm curious about timing. It seems miraculous, and you have such an incredible background. Why is it that nobody has invented this before? Why is it only possible now?
Right, ma'am. Ma'am, it's not that they haven't, there is no product out there. There are. And the thing is, they are using so there are certain polymers with us, like chitosan, gelatin, cellulose. These kind of materials you can use, and people are actually using them. And what they're doing is they're just using their inherent property of clotting. So those materials can have that some bit of property. What we are doing is we have come up with a new process altogether. So this is the new material, having those off-the-shelf polymers into it. So not only the material of construction, but also the internal structure, the way we have engineered it, also plays a major role in making it 5 times quicker than those solutions.
And how does the cost compare to those solutions and
You're right.
existing solutions?
Ma'am, we are at par with them. But we strongly believe, like, once we go for a scaled up version in the manufacturing part, we can reduce this cost almost by half. So right now we have at a 20-liter scale where we have managed to go for it. Like, as you can, like, with just $800,000, we are like starting from validations and all those. So 20-liter scale, we have done it, and our cost right now is around $3 to $4 per unit. That's the biggest one.
Amazing.
So as you think about expanding into the U.S., medical innovation, I think in general, it's a series or a marathon of those milestones, those regulatory milestones, right?
Right.
And the U.S. is obviously different than other parts of the world, including where you have started, which I think it's a very noble feat, and I'm excited to see the product in market here. But how are you thinking about pacing your team and your product kind of against those milestones so that you can stay resilient? And I'm asking, and I'm naive in this, just the idea that this is actually a medical consumable might actually make my question irrelevant, but I want to ask because I don't understand.
Ma'am, to talk about the resilience, so I quit my job to do this. I'm doing this for last 7 years. This was my master degree project, which I just took it to the startup. I'm coming from a middle-class Indian family. For what we did was with the regulatory part, because this was the biggest challenge. The moment we got to the MVP, proof of concept, we contacted US FDA. There is a process where you can submit your data to the US FDA for which called as pre-submission, and we followed what they suggested. So right now we are ready with the US FDA part also. Yes, as we don't belong here, so I don't have that much clarity about the US market, how we will be navigating it through, but I'm trying to figure out. And one of my reasons, although flying from India to here, is to find out whether this ecosystem has a place for me or not.
I will say you do belong here.
Yeah.
Don't say those words again.
Yeah.
That's not it.
I agree.
Absolutely.
Sure.
Well, we are out of time, but let's hear it for Miracules.
Woo! Thank you. Well done.
Thank you.
Great job. Just gonna take a second to get set up here. This is also gonna be an unusual demo, I think. Judges were doing okay. The images were everyone held in there. I had to look away for a second, if I'm being completely honest. How are you liking the company so far? That I was a little bit in suspense, yeah. Audience, what do you think of the company so far? Do you like them? All right, we're doing some companies that are doing some pretty ambitious things. So yeah, it can take a second to get set up, but I think we might be ready. We're good to go. Okay, let's bring out our next startup. That startup is Nephrogen. Presenting for Nephrogen is co-founder and CEO Dimitri Maxim.
Hi everyone, my name is Dimitri, and I'm the founder and CEO of Nephrogen. We use AI and high-throughput screening to develop safer, more efficient gene delivery vehicles as curative therapies for untreatable diseases. Gene therapy, or gene editing, which won the Nobel Prize 5 years ago, are completely new categories of medicine. In some ways, we're currently in the middle of a gene therapy revolution that us at Nephrogen are taking advantage of and trying to catalyze on. And although there are hundreds of gene therapies currently in development, that affect multiple different organ types and diseases, and have already been used to cure several patients. 785 are in the clinic, for example. 0 have been used to target the kidney. There's 2 reasons for this. One, the kidney has 15 different cell types, which are organized in this really intricate, specific manner. Also, 15 is the most of any cell type, the most number of cell types of any organ in the body. And 2, the kidney by nature is designed to filter out most things, almost everything, including existing delivery vehicles that are FDA approved. Why does this matter? Why is it important? Why should we care? It means that delivering to the kidney is almost impossible. But it also means that if we can deliver gene therapy to the kidney, we can potentially deliver these curative medicines anywhere. And that's what I've spent my entire career working on. My family's had kidney disease for 4 generations, and I've dedicated my entire career towards solving the gene delivery problem in the kidney to make curative gene therapy possible. I started when I was 14 years old in George Church's lab at Harvard Medical School and continued as both an undergrad and graduate student at Stanford University. Back to kidney disease for a minute before I start a demo. As a whole, it affects 10% of the global population. That's 97,000 deaths in the US per year. And the total cost that the US government or Medicare spends is $86 billion specifically on kidney disease. A lot of you in this room might know someone who is affected by kidney disease personally. In fact, you might have seen yesterday on CNN that there was a prominent former NFL player who died of a genetic kidney disease. But if I was willing to bet, I bet most of you haven't seen a real kidney before. So for our demo, which will start now, I wanted to show that to you. Okay. So on the left, or the top, I guess, from your perspective, is a kidney from a patient with polycystic kidney disease. This is a genetic disorder that causes kidney failure. Unfortunately, this patient passed away. The bottom kidney is hopefully similar to what most of us have inside of our bodies right now. So you can see the kidney on the top is 3 times larger than the other one and has all kinds of scarring and fibrosis that have caused it to fail. But what if I told you that there was a way to turn this kidney into this one, this kidney back into this one, reverse that patient's disease, and potentially save their life? And before I continue, we'll go back to slides. So it turns out there is, and we've known for 4 years, at least in mouse models, that a curative gene therapy for this patient's disease is possible. It was based on a seminal Nature Genetics paper published in 2021. The problem is, like I mentioned earlier, without a way to deliver these curative therapies to the kidney, a cure will never be realized in patients. And that's where my company, Nephrogen, comes in. We've developed 2 technologies based on my work as a grad student at Stanford to solve the kidney delivery issue. Gene therapy, importantly, if you just injected it or took it as a pill, it would disintegrate rapidly in the bloodstream. It's not like Tylenol or Motrin that you take daily that works fine. You need a delivery vehicle. And so through this process, our AI and high throughput screening, we're able to find these delivery vehicles, which you can think of as like fancy FedEx trucks for reaching the disease cells in the body. To go into more detail about our actual platform for doing this, basically what we do is we take existing vectors or delivery vehicles, these FedEx trucks that don't get to the kidney, and we make billions and billions of variants of them in the lab. So these are FDA-approved vehicles that otherwise, target other places. You can think of these as darts, like if you're throwing a bunch of darts at a dartboard where that dartboard is the kidney, those are all these different variants of existing systems. Not only can we throw 10 million more darts than our competitors due to innovations that our team has made in the actual experimental process, but when you add in our software and AI models, you can drastically reduce the number of darts that we need to throw. Using this methodology, we developed a class of vectors that are our NeoCap system that delivers very efficiently in mice 100x or 2 orders of magnitude more than the existing FDA-approved vectors. And for the first time publicly, we're disclosing data today, live on the TechCrunch stage, our data delivering in a live human tissue as well. This is like in a pumping system to keep a kidney alive outside the body, and we've shown that NeoCap delivers into kidney in this system. This is currently undergoing the standard scientific peer review process for publication in a major journal, but we wanted to release our data today as a preprint so that you can all get a chance to read it earlier. We have a two-tiered business model where we're starting by licensing the delivery vehicles from our system to pharmaceutical companies. We've already shown significant traction on this path by closing over $600,000 in research sponsorships. In tech speak, you can think of that as a paid pilot. And although our initial market is licensing to these pharma companies, our longer-term vision is to sell our own developed drugs directly to patients.
Wrap it up.
I'll close by just saying that this is the team behind this work. Myself, I'm the co-founder and CEO. My co-founder is a leading nephrologist from Stanford, and our team includes field leaders in gene therapy and kidney disease. And we were looking for investors to join our seed round, which we're halfway through, including the syndicate shown on the stage, and would love to connect with others interested in our mission. Thank you.
All right. Good job. I'm 99% sure the first startup to bring kidneys, outside of our bodies, onto the stage at Disrupt. Judges, who has questions?
I'll ask the first question here. First of all, congratulations. This is really interesting, and I'm very interested in this whole field, and we've done a lot of investing in this field. Question for you is, how are you actually using AI? Because a lot of people say they're using AI for drug discovery, and here you're using it for vehicle discovery, but how are you actually using it?
Yeah, so I'll caveat that we didn't start by using AI. When we started this, when I was a grad student, there was no AI part of it. Now really what it is it's just a better way to predict like that design space of total combinations of this existing delivery vehicle, which is called an AAV, but there's 10 to the 1,000 combinations. So AI, and we can only screen 10 to the 17th. So we're basically like an infinitesimal amount of the possible experimental design space, so the AI can drastically reduce the rest of it. And basically what you're doing is you're training the experimental data on models so that software, you can basically say this part of the vector is just non-functional, so you don't need to screen experimentally in this space, whereas you can in this other space instead. It just reduces the amount of experimental work that we have to do.
Yeah. So follow up to that on the agreements that you have with the list of pharmaceutical companies. Congratulations, that's awesome.
Thank you.
Why did they choose you to do those with?
I think, to be honest, and I would have to ask them directly, but I think really it comes down to just there's very little being done in the kidney. Like, it's a huge unmet need in a medical term. And like Dino Therapeutics is a competitor that came out of actually my lab. I was a visiting scientist with George Church, so we're friends. But they make capsids for the brain and for the muscle and the eye, and so they're not touching kidney at all currently. And I think our whole thesis of the company is like you need data sets specific for kidney because there's 15 different cell types. And so we build off of the work that my co-founder, a nephrologist at Stanford, and then when I joined the lab, to essentially solve this kidney-specific issue. And now we're thinking of expanding to pancreas and other really like hard-to-access diseases. But as a whole, I think they're really betting on kidney as a whole, these pharma companies, and we're sort of one of the leaders in that space right now.
Excellent. Thank you.
Kudos to you for taking a very scientific innovation and making it digestible. That's really hard to do. Can you talk a little bit more about what the seed round unlocks in the short term for you?
The main milestone is really a larger licensing deal. So these like research sponsorships, they're formally called like golden tickets, are help us, and they help us validate our work at an early stage and provide validation. But the big money is in like a larger upfront licensing deal where it's many millions up front, and then there's like milestone payments when they get to clinical trials, and then there's a royalty on drug approval. And that's really the business model that in this space I think is most successful, because you can't really rely, otherwise you become a CRO where you're just doing research for pharma companies. So I think the seed round really unlocks the additional experiments that aren't covered by the sponsorship funds to allow us to do that.
Maybe touch on something I want to understand. First, amazing you went for the hardest problem that no one is going for. But what do you see as the ultimate dream for you, like 10 years from now? Is it going through an acquisition? Is it going through your own company and making it big? What's your dream?
Yeah, well, my dream is to cure my own kidney disease. So that my kidneys might look like that, unfortunately, if I don't act fast. So that's my longer term vision. But I think the way that you do that is like having as many shots on goal as possible. So like we're licensing to pharma. We also want to develop our own drugs. And like if we can be the first ones to succeed clinically in patients and delivering in the kidney, whether that's a pharma company that's taking our technology forward or ourselves running a clinical trial, if we can succeed in the delivery piece, I think it unlocks a lot of different disease options. And so 10 years from now, I'd love to have as many drugs approved as possible, whether that's a pharma company or our own pipeline.
Okay.
How do you think about pricing and accessibility? From where I sit, a lot of the challenges we see is there's these incredible innovations, but when it comes to getting them covered by insurance or actually getting them into the hand of end patients, there's a lot of messed up incentives. Is that on your radar? How are you thinking about making sure that this doesn't get stuck in the ivory tower of pharmaceutical companies and it's too expensive for regular people to get access?
No, it's a great question. Just to go into a couple things. So the first one is like we started this journey at the patient level. So we actually have data, again, I didn't get into it in the pitch, but like on a patient survey of asking them the current standard of care versus a gene therapy, like would you want to take it, period, right? And look, 80+% of survey applicants said that they wanted a gene therapy, but then when you get to the pricing piece, okay, it's a single dose, right? So it's a big upfront cost that's saving Medicare or other like insurance companies a lot of money downstream. So the way to avoid that is to just make sure that you have like a value outcomes-based payment model, which when we talk to payers is sort of like Zolgensma, which is the successful AAV gene therapy from Novartis. That's how they do it. So you pay it out over time. The payers still pay, but it's over time. I know we have 3 seconds, but the last piece on that was just the access to therapies more broadly. I think is something that because we're using such a low dose and because the vector is so targeted, we're able to charge less because our cost of goods is a lot lower.
Thank you.
Excellent.
All right, give it
done.
up for Nephrogen.
Thank you.
Well done.
Thank you.
Okay, I know we've shown you some various body parts and functions in the last two companies. I think we're going to have a little bit of a change of pace here. So let's bring out our next startup, COI Energy. Presenting for COI Energy is founder and CEO Celisa Berrien.
Really? Okay.
You know the feeling when the power goes out during a storm? The quiet, the uncertainty, the darkness? For my family, those moments were not caused by storms. It was because my parents could not afford to pay the electric bill. We'd sit in the dark with candles flickering, kerosene heaters running, waiting for my dad to get the money together to pay the electric bill. Those moments shaped me. It made me ask the question, why in these United States of America, a third of the population still sits in the dark? That question motivated me to start a career in energy efficiency. My name is Celisa Berrien, and I am the founder and CEO of COI Energy. We're on a mission to eliminate energy waste and repurpose that waste for good. We all know that electric demand is growing. It's skyrocketing from a 2% growth rate to more than 15% over the next 5 years. This is due to AI, data centers, electric vehicles, and electrification, all having an enormous pressure on the grid. Meanwhile, a third of the energy consumed by businesses is wasted. That's over $35 billion being thrown out the window every year. As my grandmother would say, when you know better, do better. So to do better, COI Energy, we have created the first marketplace for recycled energy capacity. We call that the Excess Energy Exchange, or E²X, where we're enabling businesses, instead of wasting energy, the unused capacity, they're able to share it. So let me break this down for you, because most of us don't pay an electric bill for a business. So businesses are charged for peak demand and for their consumption. Unlike us as consumers, we're only charged for our energy consumption. So when you look at the building, it has a base load and it has a peak demand. That peak, most businesses peak less than 20% of the time. So that means that businesses are paying for capacity that they're not using. So if you pay for something, you own it. So we're helping businesses monetize that with our simple business model. Businesses pay a monthly subscription to access our services at the level that they wish to do. And then with that, they also pay a monthly transaction fee. So a transaction for all transactions executed on the platform. In addition, every business on our platform pays forward 1% of their savings towards energy equity. So at this time, I'm going to have my colleague start our demo to show you a little bit more about what we're doing.
Thank you, Celisa. This is our main dashboard that shows the KPIs most important to a business. We can see the total revenue generated, energy reduced, carbon reduced, and seller and registered capacity available to sell. From here, we can go into the account view to see the real-time energy data and the asset registry. The assets are used to control customer load if needed. Let's try selling some capacity. Our platform uses historical data to forecast the recommended amount. We simply go to the recommendations button, accept it, and that's it. Our offer's on the market. Buying is just as easy. Let's take the Moscone Center, for example. They knew they were having this event today, so they went to our platform to purchase 400 kilowatts of capacity to cover the increase in their demand charge. They simply select an energy resource type and hit request. From here, our matching algorithm takes over. All seller capacities are aggregated into a single pool and matched with buyers, ensuring reliability for everyone. Back to slides.
So as you could imagine, the market for unused energy capacity is massive, $124 billion. And this isn't a theory. We actually have traction to prove it. We have 5 pilots that encompasses 50 buildings with the potential to grow to over 3,000 buildings. We have 17 waitlisted customers and a pipeline of over $23 million in ARR. Our go-to-market strategy combines direct sales, channel partners, including international companies that are pulling us to come there, referral networks, and tech integrations. So you might be asking, what sets us apart from everyone else? Our disruptive energy model is the first of its kind. I know everybody's sitting here like, I never heard that before. We also have 3 patents and 2 pending. We have a 2-sided marketplace that scales as more buildings join the platform. And our strategic global interest in our technology. But let me not leave out my team. I have a rock star team that is best positioned to solve this problem. We have over 100 years of collective experience in energy, tech, and in property management. And myself personally, I spent my entire year working in energy space. I worked for 3 investor-owned utilities, and I worked for 4 clean tech startups. So you can probably imagine why we are excited about what we're about to embark upon with this explosive growth, growing from $2.5 million in sales to over $123 million in sales over the next 5 years. So with that, we're raising a seed round. We're looking for investors that have experience in marketplaces, enterprise sales, and regulated industries. And we want our partners to see energy as that next great shared economy opportunity. So our vision is simple. We're creating a new energy infrastructure where no business leaves capacity untapped and no family is left in the dark. If this resonates with you, we ask you to join us on this journey. Thank you.
Judges.
That's amazing. So thanks for showing us the light. This is an incredible business model. And I love Carla Harris, by the way.
Oh,
old friends with Carla. I'd love to hear how you get people on both sides of the marketplace, because it makes sense for this to be a 2-sided marketplace, but how are you gathering the forces on both sides?
That's a great question. So all the sellers, they are able to recoup up to 70% of their unused demand charges. And then on the buyer side, they get to receive up to 30% in savings over the utility bills.
And
so everybody saves.
How are you getting them to come? I mean,
really simple. So from a direct sales perspective, my background is in business development. So I worked at 4 startups, helped one IPO, and with that IPO, because of my what I call my superpower, I'm able to really develop these sustainable relationships with multinational companies. So we were able to grow to the UK just because of what I did for that company, and that's what I do here at COI.
Fantastic.
So maybe I have a naive questions, but is it not all at the same time that they have peak energy? How does it work when it's peak somewhere but not the other place?
That's an excellent question. So when you look at the power grid, the reason why our platform is so powerful for utilities as well is because they can't see behind the meter what's happening inside of a building. We're able to see when a business is peaking and when they're not peaking. And so that's how our algorithm is able to make these recommendations and say, okay, you're gonna peak on this day, so all these other days you have capacity available to sell. And then a buyer, like he said, the Moscone Center, they're like, we're having an event next week. So our demand is going to go up because we're having this big event. So like, I'm going to go on there. Instead of me peaking on the electric grid, I'm going to just share in recycled capacity. And it saves for everybody, the environment, the government, like for the utilities and for the businesses.
Then I had one question about your 70% price and 30% discount. It sounds like you're leaving nothing for you. Can you speak to your margins and unit economics?
Yeah, no, so we get our monthly subscription, we get transaction fees, and we get a part of that, they get up to, so they don't get the full amount. It depends on what market they're in, on what they get, but we get a portion of that as well.
Okay.
Do you need the cooperation or permission of the energy utilities? Like, how do they feel about the existence of COI?
Yeah, so every utility now that I've talked to, except for one, I was like, this is super amazing. It's a good way to squeeze more out of existing infrastructure because we cannot build quick enough. When we talk about AI and these data centers, everyone's trying to figure out how to solve that problem. They can't build quick enough, so they're like, this is a solution that can help us. And because they don't have the technology to see behind the meters, we're able to help them see that, and we do the measurement and verification so they know that a building did what they said they were going to do, and then this buyer actually was able to buy off our platform.
I had a very similar question. I'm glad you asked that. I also was surprised to see the growth demand go only up to 15%. I actually expected to see a higher number just based on the energy consumption that people are predicting. So it was nice to see some data behind that. I'm curious about your pilot programs. So thinking about your favorite or your first or your best or your gold standard pilot, how are you thinking about turning that pilot program into a playbook for scalability?
Yeah, so with our pilots, because of my background, I don't really truly believe in saying a pilot. Every customer that we bring on board, we set it up that it's a multi-year contract.
Oh, nice.
So we're not looking at just getting you on, if what we say we're going to do, we do it, customers are happy. So my background, I've never lost customers, literally never lost a customer. And it's just because of the sticky relationship that we develop. Do what you say you're going to do, and your customers are delighted.
That's a wild concept. Integrity.
Exactly.
I like it. Good moat.
Yes.
Leaning into the customer side, oftentimes energy solutions have failed because they require some sort of behavior change. Who exactly are you selling to and collaborating with at the corporations that you're bringing onto the platform? And then what kind of behavior change is required from them, but also from the organization at large?
That's an excellent question. So we are focused on, depending on the company, so we are only targeting enterprise businesses. So we have a Mag 7 that we're currently on our platform, so big tech company. We have a healthcare consortium, and then we also have big box stores in a city. So they all have a whole lot of buildings, right? In different categories, it might be an energy manager, it might be a global a sustainability officer. It depends on that company. So we are kind of targeting those customers that way.
You talked about superpower. Can you talk more about your superpower and your teams?
Yes, I mean, my team is super amazing. I, as you know, have been in this field, and it's really comes from my passion. People are like, why do you get up every day and do this? Because it's not easy, right? For me, I really see the world being a better place when we're able to help not only ourselves, but we're able to help all people. You know, people usually say, like, they should pull themselves up from their own bootstraps. But if you don't have boots, and we learned that during the pandemic, that people didn't have boots, but we didn't want to get COVID, so we made sure we got masks out to those people. It's the same thing, and so that's where our energy equity piece is tied into our business model, because we feel it's important. And for me, I'm passionate about that. If you look at my career, do any little search on me online, you'll see that's what I'm about, is really making a difference for all.
Your passion is clear.
Thank you.
Yeah.
All right, let's hear it for COI Energy. And we have one final startup in this session of the Startup Battlefield. That startup is RADiCAIT. Presenting for RADiCAIT is co-founder and CEO Sean Walsh.
Thank you.
Hello, ladies and gentlemen. I'm Dr. Sean Walsh, CEO and co-founder of RADiCAIT. The world faces a grand challenge. Last year, 100 million people were diagnosed with either a cardiological, neurological, or oncological condition. That number is going to double in the coming decade due to global demographics. And did you know that current practices in radiology cannot meet that demand? Let me show you precisely what I mean. This is a CT scan, the mainstay of radiology. Your doctor orders this when they suspect something serious, and they need a map of your anatomy to investigate. They're great because of accessibility. 90 million performed in the US last year, largely due to just how efficient they are. It's a simple 5-minute procedure. You jump on the table, you jump off the table, you're done. And in the world of healthcare, these are relatively cheap, a few $100s. Now, this is a PET scan. It's the most advanced form of medical imaging. Your doctor orders this when they need physiology GPS to go with that map of anatomy. And in the case of this patient, clearly reveals lung cancer. So they provide absolutely critical clinical insight. The problem is there's a supply shortage. Only 2 million performed in the US last year. That's a long way from 90 million, and that fall off a cliff is due to just how slow and complex these things are. I mean, for starters, your city needs a cyclotron and your hospital a nuclear medicine department. You need to fast for 6 hours before the procedure, be injected with a giant needle filled with chemicals that literally make you radioactive, wait an hour while that washes through your body, climb into the scanner, try to lie perfectly still for 30 to 40 minutes while the images are required. And naturally, they're expensive, costing between $5,000 and $10,000. So for the non-radiologists in the room, take-home message from the intro: CT scan, simple map of the human body; PET scan, complex, GPS-enhanced visualization of the human body. Now imagine, we could use the CT scan to generate the PET scan and deliver critical clinical insights at scale. A solution 10 times more accessible, productive, safe, and sustainable. Ladies and gentlemen, introducing to you RADiCAIT's in silico PET, the future of healthcare. This AI software as a medical device works by leveraging all the virtues of a CT scan plus the power of our proprietary AI to deliver all the value of a PET scan. This is a game-changing breakthrough. This is disruption of the PET industry. We achieved this through data agreements with major health systems across the globe. Using millions of data points, we've developed a foundational AI that's learned the translations from CT to PET, from anatomy to physiology, from structure to function. This seems like magic. It's the very best kind of science, backed up by a patent portfolio granted in America and Europe. We are spun out of the University of Oxford. We're collaborating with Mass General Brigham, UCSF, and other leading health systems across America, providing the FDA with the evidence required to take this technology into the clinic. And now, it is my distinct privilege and pleasure to introduce you, our outstanding collaborator, Dr. Thomas Johannan, radiologist at UCSF. Please, Tommy, show us the power of the technology.
Hi, everyone. Thank you for the introduction, Sean. I'm Dr. Thomas Johannan. I'm a nuclear radiologist at the University of California, San Francisco. So every day I look at scans like this one, and we see a small spot in the lung. It could be nothing, or it could be something more serious, like lung cancer. And right now we have 3 main options to further evaluate this nodule. 1, we could get a follow-up CT scan in a few months and see if there's a change. But that involves more waiting, uncertainty, and a potential delay in a cancer diagnosis. 2, we could go straight to a biopsy, by which we inject a needle under imaging guidance into the nodule and get tissue. But this is invasive, carries risks, and ultimately may not be necessary. 3, we could get a PET scan, which again involves injection of radioactive materials, added cost, and can take up to several weeks to obtain. For a patient like this, typically we would proceed with the PET scan. However, in the near future, we could have a 4th option, a variation of the 3rd, seen here on the right, as the next best step. So we've proceeded with ordering RADiCAIT's in silico PET, using AI to generate PET equivalent images from the existing CT data alone. And within seconds, we have the same data that would normally take weeks to obtain. And if we look at this patient scan, we see that this nodule is highly avid. So we would forego the potential steps of getting further imaging with CT or PET and go straight to biopsy, because something this avid is most likely a lung cancer, and time is of the essence. So this type of clinical impact is why we're excited to work with RADiCAIT on developing the clinical evidence to deploy this technology. It could make advanced imaging and evaluation more timely, less invasive, and more accessible. Thank you.
Thank you, Tommy. Together with our clinical colleagues, we are the right team to go after this grand challenge. I'm a serial entrepreneur with 20 years' experience leading in radiology AI. Regent is a full professor of interdisciplinary innovation, JP, a seasoned operator in startup environments, Cinna, a proven hyperscaler of cutting-edge tech. I'm closing on this slide. Our technology is disruptive, but our business model is harmonious. We've validated with providers the clinical care pathway. We've validated with payers the reimbursement pathway. We'll be revenue generating in Q2 2027, post-clinical trials and regulatory approval. We're opening our seed round here at TechCrunch. If you wish to join us on this transformational journey, let us know. Thank you.
Okay, judges.
I'm wondering a little bit about the size of the training sets that you need to create the kind of data you need to be able to go from the CT to the PET, and how you're acquiring those. Obviously, you've got some partners here. And then a follow-up question to that, which is, there's obviously some very large players in this space that have very large training sets with both of those in them, and how you're going to compete with them.
Wonderful. Yeah, so with pleasure. So yeah, you need large data sets. That's one element. So we have, through the University of Oxford, a data silo of more than 1 million images, which is there. But AI are just like people. Some people need lots of examples to learn something. Some AIs, you give them one example, they get it. So the secret sauce behind what we do is a multi-scale generative AI architecture. Happy to go into the detail on that. But we can get these insights with tens of thousands of images. This is a competitive advantage. And the science is published, the patents are filed, so this is something we have. In terms of competing with other providers, yes, the large vendors, Siemens, GE, Philips, they have scale, but they don't have our ability to execute what we're doing with the partners we have. They can compete with us, but there's a natural transition there. We're going to be first to market with this because we've got our trials up and running. We're going forward with that. Regulatory is aligned with our IP, so if anyone follows us to the market, they've directly infringed our IP. No questions asked. So we have a defensibility moat there. So I hope that addressed your point.
Yes, thank you.
How do you think about the clinical workforce shortage that likely exists if you really are able to generate that many more images? How will you find the people to read them?
Yeah, wonderful. Thank you. Please, Tommy, this is your field. I have an opinion, but let's get it from the source.
Yeah, so I think this technology actually would reduce the number of PETs that we do chemically and see. So we presented the example of a CT scan. So, and then we have those 3 decision points. And oftentimes, a PET is being ordered in this scenario when it's really not needed. CT or biopsy really are the ultimate choices. So it would actually, I think, help us by reducing the clinical volume overall.
And would people that are only qualified to read CT scans today be capable of reading your enhanced CT scan as well?
So everyone that does a radiology residency in the United States is qualified and board certified to read the PET technology. But we do fellowships afterward to get extra expertise. Like in my institution, only specifically nuclear medicine trained people read PETs. But hopefully this technology could be presented in a way such that like someone just reading the CT would have the expertise.
And to complement that, so what Tommy is speaking to is this is efficiency in the health system, right? We are going to be able to enable radiologists to get their work done faster, so the human shortage, this is important. We're not trying to automate their tasks, we're trying to improve their decision making. There's a lot of gray area of wasted time and energy getting to the ultimate outcome. So we are definitely improving that unit economics on. And second, in terms of how to use it, first you would displace PET, 2 million. That's a market and is very valuable by itself. But the potential here is the unlocked market of 90 million CT scans. And how do you go? There's a trade-off here that you have to optimize for between the price point today versus the volume increase. because you've got to work with payers to make sure that the health system overall, the economics are sustainable and value-driven. So that's how we do it. We come in at the price point of a PET, but if you're doing 90 million of these in silico PETs, you're not going to. So there's a transition there that goes underway.
It is a beautiful use of AI. But if we think about liability, because AI doesn't tell you everything, like in this case, probably a black box. How do you think about false negatives where the patient would walk back thinking he has nothing to worry about, but you didn't catch it while the PET would have caught it?
So I'll just go quick, Tommy, and then please come, make sure to validate what I say. So indeed, the FDA will only let this on the market if we demonstrate that this in silico PET is having the accuracy, true positives, true negatives, false positives, negatives, sensitivity, specificity, at the same rate as chemical PET. So we are not inferior. We are going to be directly interchangeable and have the exact same performance. Beyond that, though, this is a bit secret sauce, but we have the ability to go beyond PET. There's clear issues with PET, which I'd like Tommy to comment on now, how we can actually produce a solution which is going to be better. But Tommy, please contribute.
Yeah, so like PET scans have false negatives. Like we know certain lung nodules that are lung cancer, they won't be FDG avid. And actually, I think this technology will help because sometimes we get PETs for some things we know as radiologists won't be FDG avid, and they'll come back negative, and we're like, this is a cancer, even though it's not FDG avid. But the person who ordered the PET scan may not understand that, right? They may think that, oh, this is negative, this is not a lung cancer. This technology may help us to explain, okay, we see this CT, we think this is lung cancer. We used RADiCAIT's technology to show this is unlikely to be FDG avid, so you don't need to get the PET scan, but this is still most likely a lung cancer. So it actually could take away that unneeded utilization of a PET scan to characterize this nodule when we know there's going to be a false negative.
Tommy, is this also super helpful in the market where PET scan is contraindicated, like for a pregnant woman, child?
Answer quickly.
Yeah, so this will reduce the overall radiation exposure if we can, right, because radioactive materials that are injected would cause more radiation exposure.
All right, give it up for Radicate.
Thank you. Thank you.
That concludes the first round of the Startup Battlefield. Thank you all for watching. The judges are going to follow me off stage where they're going to help us choose finalists who will be presenting on Wednesday. Before they leave, though, let's have one more round of applause for all the Startup Battlefield founders and our amazing judges.